Hey, what's up, Mr. Sutter here. Today we're going to be looking at Newton's second and third laws of motion. All right, so let's get right into it. Newton's second law. So force is equal to mass times acceleration. We write that as F equals ma. Remember, acceleration is a measurement of how quickly an object is changing speed or direction. So what does F equals ma mean? So force is directly proportional to mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now imagine we make the ball twice as big. We double the mass, but we keep the acceleration constant. We keep the acceleration the same. F equals ma says that this new ball has twice the force of the old ball. So let's see if that's true. So we have our formula here, F equals ma. In this case, we're going to have our mass equal to and our acceleration equal to. Right? So then we're going to double the mass like we said. So now we have a mass of 4 instead of 2. In the first example, 2 times 2 is 4 newtons as our force. In the second example, 4 times 2 is 8. So yes, it's true. If we double the mass, we also double the force. All right, so now imagine the original ball moving at twice the original acceleration. F equals ma says the ball again will have twice the force of the ball at the original acceleration. Again, let's check it out. F equals ma down here. Oop, fell on top. F equals ma down there. Right, so again, we're going to have 2 be our mass and 2 be our acceleration. F equals 2 times 2. And then we're going to double the acceleration over here to 4, right? When we multiply them out, 2 times 2 is equal to 4 newtons. And then 2 times 4 is equal to 8 newtons. So again, we can see that our total force doubled when we doubled our acceleration. A little more about F equals ma. If you double the mass, you double the force. If you double the acceleration, you also double the force. We just saw that. What if you double the mass and the acceleration, right? So if we double the mass and we double the acceleration, 2 times 2 is 4. If we double the mass and we double the acceleration, we quadruple the force. So what happens if you decrease the mass by half? How much force would the object have now? Right? So if we have the mass, we also have to have the force. So the force is going to be half. Whatever you do to one of the variables, you have to do to the force. So if you double the force, if you double the mass, you double the force. If you have the mass, you then have the force. Another example with F equals ma. So John's got this van here. His van weighs about 200 kilograms, but it's out of gas. John is trying to push the car or his van to a gas station, and he makes the car go 0.05 meters per second. Remember, meters per second can also be written as meters per second squared. That's our acceleration. So using Newton's second law, you can compute how much force John is applying to the car. Right, so we're going to substitute in here. Remember our formula, F equals ma. So we substitute in here our mass, 2,000 kilograms, our acceleration, 0.05 meters per second. 2,000 kilograms times 0.05 meters per second is 100 newtons. So John is pushing on that van with 100 newtons. Again, we used our formula, F equals ma, to find that answer. So what does F equals ma say? F equals ma basically means that the force of an object comes from its mass and its acceleration. So this means that something very massive, means a very large mass, a high mass, something very massive that's changing speed very slowly with a low acceleration, like a glacier, can still have a really great force. And something that's very small with a low mass that's changing speed very quickly, a high acceleration, like a bullet, can still have a great force. So even though an object might be very large and moving very slowly, it can still have a very large force. And even though an object is very small, as long as it's moving very quickly, has a high acceleration, it can still also have a great force. Right, that wraps it up for Newton's third law. Let's look at Newton's second law. Let's look at Newton's third law now. Right, Newton's third law says that for every action there is an equal and opposite reaction. So what does this mean? For every force acting on an object, there is an equal force acting in the opposite direction. So right now, gravity is pulling you down in your seat, But Newton's third law says that your seat is pushing up against you with equal force. So that's why you're not moving. That's why you're not falling through the chair and accelerating into the floor. There is a balanced force acting up on you as gravity is pushing you down. So again, gravity pulling you down and the chair pushing you up. Because those forces are balanced, you sit on the chair nice and calmly. So think about it. What happens if you're standing on a skateboard or a slippery floor and you push against a wall? You slide the opposite direction away from the wall because you pushed on the wall, but the wall also pushed back on you with equal and opposite force, which caused you to move in the opposite direction that you were pushing in. Right? So why does it hurt so much when you stub your toe? Well, when your toe exerts a force on the rock also exerts an equal force back on your toe. The harder you kick your toe against the rock, the more force the rock exerts back on your toe, and the more it hurts. Still thinking about it here. So why does a balloon move through the air when you let go of the closed end? Well, Newton's third law, again, says that for every action, there is an equal and opposite reaction. The example above, as the air is released, it exerts a force to the right. Now, the equal and opposite reaction to the force of air being released to the right is the balloon moving to the left. So because the air is being released to the right, then the balloon moves towards the left. Right, so some recap here. Newton's first law, objects in motion tend to stay in motion, and objects at rest tend to stay at rest unless they're acted upon by an unbalanced force. Newton's second law, force is equal to mass times acceleration. And finally, Newton's third law, for every action, there is an equal and opposite reaction. Right, that's going to wrap it up for Newton's second and third laws. Thanks for watching. Hope you learned something, and I hope to see you in the next video.